Hi everyone, I'm Sangwoo Kim. When we are familiar with the analysis tool, we are getting far from statistical theory or mathematics. Having said that, in this video, I would like to share how to get the output of regression analysis manually in Excel. I hope this video helps you wake up your brain. And at the end of this video, I will also show you how to do regression analysis by R. Please click like and subscribe to motivate me to upload more useful videos. Let's start. I have prepared very simple data. There are 12 observations. In order to do regression analysis in Excel, click Data tab, and there is Data Analysis on the right side, and choose Regression. Click OK, and choose Y range, and choose X range, and click Labels because the first row is about variable name, and we want to put the output in this spreadsheet, so choose just one cell and click OK. Alright, as you can see, we can easily get the regression outputs by Excel tool. However, as I mentioned in this video, I would like to get these data manually. So let's do that. Copy and paste and delete everything. We're going to get this number manually, right? So we need to calculate those 5 columns to fit in this ANOVA table. So let's get it. First one is x minus x bar square. So x minus x bar can be calculated by average function. And press F4, close the form, and square. Okay, for y hat, we can use intercept and slope function. So intercept and choose y. Press F4, comma, press F4, plus slope, and choose y, and press F4, comma, and choose x, and press F4, multiply by x value. Double click it. Alright, so from now on I want to calculate TSS, SSR, and SSE. TSSR means total sum of square, so y minus y bar, press F4, close the form, and square it. For SSR, we can calculate y hat minus y bar, press F4 and close the form, and square it. Alright. For SSE, which means sum of square of error, so y minus y hat and square. Alright, so I'm going to calculate sum and degrees of freedom to calculate quickly and easily. So sum of this one is this one, and okay. In terms of degrees of freedom, total sum of square is y minus y bar, means number of observations 12 minus y bar as one value. For SSR, y hat minus y bar, so it means p minus 1. So there are two parameters B0 and B1. So 2 minus y bar takes one value, so 1. And for SSE, there are 12 observations minus y hat has 2 parameters, so 2. Alright, so for degrees of freedom for regression is this one, right? And for degrees of freedom for residual is this one. And the degrees of freedom for total is this one. Alright. In terms of sum over square for regression, regression here. For sum over square of residual is this one. And total sum over square is this one, right? For mean square, sum over square over degrees of freedom, and mean square for residual is sum over square over degrees of freedom. Okay, and for F statistic, we can get it by regression, mean square of regression over mean square of residual. Alright, so for p-value for F statistic, we can calculate like this way. So 1 minus, because we're going to take right side of F distribution. So F dot dist, and x is this one, and comma, and first degree, comma, and second degree. Sorry, I need to define whether that is false or true, right? So we will take cumulative, so true. Alright, so this one and this one is same. And we're going to use this MSE a lot for the rest of calculation, so I'm going to highlight orange. Okay. For coefficients, we can consider Excel built-in function. For intercept, we can consider intercept function and choose y, comma, and choose x. For B1, slope function, and choose y, and comma, and choose x. Alright, so for the rest of the calculation, I'm going to show you the formula which I'm going to use. So for standard error for intercepts, okay, this formula. So QRT MSE multiplied by 1 over number of sample size 12 plus average of x and square and over this one. Okay, and close the form. Alright, so as you can see, this one and this one is the same. And for standard error of B1, I will use this one. It's QRT and MSE over x minus x bar square. Alright, so yep, same standard error. In terms of t statistic, so we can get t statistic by coefficients over standard error. And for B1, yeah, same, coefficients over standard error, right? For p-value, we can consider t distribution. So with two side t dot dist dot to t, and degrees of freedom is this t statistic, and comma, and degrees of freedom is 10. Okay, and for B1, we can use t dot ist dot to t, and t statistic, and comma, and degrees of freedom is 10. Alright, so yeah, same result. Okay, for confidence interval, for lower 90% and upper 90%, I'm going to use this formula. Okay, so for lower, we can get V0 minus t dot inv, and 1 minus alpha over 2 is equal to 0.975, right? And comma, and n minus 2 is equal to 10, right? And multiply by standard of V0, this one. Okay, right, same result. And for lower bound for B1, we can consider, yeah, we're going to use this one. So B1 minus t dot dist, t dot inv, probability is 0.975, comma 10. She is wrong. Yeah, so I need to multiply with standard error, this one, right? Sorry. Alright, so for upper 95, we're going to apply same formula, but change minus into plus. Alright, and for lower 95, yeah, same formula, but change minus into plus. Right, so as you can see, all data value is same as the built-in analysis output, right? So the rest part is this one. So multiple R, we can get this multiple R by SQRT and SSR over total sum of square. And Rsquare is SSR over, yeah, total sum of square. For adjusted Rsquare, I'm going to use, yeah, this one. So 1 minus SSR, SS residual, this one, and minus degrees of freedom, but we need to use parentheses, and over SS total over degrees of freedom, right? Yep, same one. So you know, adjust the R square we use this adjust the R-square when there are many variables. So as you know, when there are more and more variables, R-squares will increase. So in that case, we need to use adjusted R-square, right? And standard error. So we can get standard error like this way. Okay, so SQRT, and yep, this one is it yep, MSE, so this one and over 10, right? Yeah, cool, same. So also we can get this one from MSE, so SQRT, yeah, this one. All right, so I showed you how to get regression outputs manually. So if you are familiar with Excel built-in analysis, you can easily get this output. Yeah, but also manually we can get ANOVA table. If you are familiar with R, just like once you read raw data, and if you use LM function, you also can get same result, right? Yep, I hope you have enjoyed watching this video. Please like and subscribe to help you get more video clips. Thank you.